Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Am I properly audible and visible to all of you? Please confirm once in the chat box. Good evening all of you. Good evening Kiran. Yes guys, please confirm once in the chat box. Am I properly audible and visible to all of you? Everything is working fine? Yes, thank you, Neetu. Okay guys, so welcome all of you. So today we are going to solve the IIT KGP special questions, that is previous year questions from the year 2000, 2006 and 2014. Hi Raja, good evening, welcome. Good evening Utkarsh, welcome all of you. I'm good Raja, how are you? Yes, thank you Pranav, thank you Utkarsh. Good evening Yogesh. So guys, before starting this session, I would request to all of you to kindly like this session and share with your friends so that those who are preparing for GATE 2022, they can get the maximum benefit of this session, right? Because here I'm going to solve all the questions from these 3 years of compiler design, that is 2000 year 2006 and year 2014. Hi Tahir, good evening. Yes guys, do share as much as you can so that everyone can get the benefit. And without waiting, let's start. So before starting, let me introduce myself. My name is Anshul Sharma. I have 1+ years of teaching experience. In GATE 2020, I have secured All India rank 294. I have also cracked ISRO and NILAT exam, mentored more than 1000 students as of now, and these are my area of expertise. Hi Shashikala, good evening. These are the star faculties we have at BYJU'S Exam Prep for Computer Science. And we are providing online classroom program for GATE aspirants, unlimited live classes and mock test to practice. We have 3 variants. This Vision Gate 2022, that is for GATE 2022 aspirants. Rank Up Gate, that is a practice course for GATE 2022 aspirants, so that if you have prepared well, you can practice this through this course. And we have Vision 2023 for GATE 2023 aspirants. For more details, you can always contact on this number 96500 Happy Navratri to all of you. Yes, Utkarsh. Thank you. Okay, guys. And this is the Mega Mock Challenge schedule. So you can attempt all these tests for free only on BYJU'S Exam Prep app. Okay. So install the app and you can start attempting this mock test for free. Okay, according to the live dates. Good evening, Parth. Yes, guys. Without waiting, let's do it. This is the first question on your screen and this is from the year 2000. Yes guys, do share and do like the session as much as you can. Very good evening Abhishek. Yes guys, start solving this question. Question number 1. I hope the question is visible to you now, all of you. So in the year 2000 and before that also, there used to be subjective questions. So here we are going to see, Raja, options are not there. Okay, this is a subjective question. So you just have to evaluate the final value, and in the question B, you have to find out the total number of reductions will be performed. Okay, options are not there, guys. Just tell me the answer. Okay. In the first part, you have to find out the value, E dot value. In the second part, you have to find out the total number of reductions that will be performed. Hi Anshika, good evening. quickly solve it and let me know what should be the answer. Then we are going to solve it. And guys, do like the session, share with your friends in all the Telegram groups and WhatsApp groups, so that those who are preparing for it, they can get the benefit of this class. Okay, because BYQs are the most important part in your GATE preparation. If you are solving those questions and if you know how to solve it, if you know the proper concept, that means your chances in doing well, your chances in the GATE for doing well is really high. Okay, Raja is saying 12 should be the answer for part A. Anshika is saying -4. Yes, anyone else getting the answer for this? See, this is very simple question. You don't have to construct the parse tree. Even if in the part A they are saying that construct a parse tree for the expression, but here we no need to evaluate, no need to construct the parse tree. Directly you can solve it. Yes. So directly we can solve it. This is the expression given to you, 4 minus 2 minus 4 star 2. Correct? Now according to this given SDTs, we can just find out the precedence and associativity of all the operators present here. Correct? So as you can see, we have two operators here. One is star and one is minus. Clear? And the actions we are performing here in the translations, that is also same, multiplication and minus. Correct? Now here, if we talk about the precedence first, so the operator which is farthest from the starting symbol, that is going to have the highest precedence. So we can say subtraction, that means minus is going to have the highest precedence here. What about the associativity? So you can see here it is t, here it is f minus t1. So as it is right recursive, as this production is right recursive, so we can say minus is right associative. So first we are going to evaluate like this, and then this one, then this will be performed. So we can write 4 minus 2 minus 4 will be minus 2 only, and this multiplication. So 4 plus 2 will become 6. 6 multiplied by 2 will be the 12 will be the answer for this part A. Is it clear? Yes, Tahir, yes, Kanchan, Utkarsh, all are correct. Now let's talk about the total number of reductions. Yes guys, what should be the answer for part B now? What should be the answer here? Raja is saying 6 reductions will be performed. Yes, anyone else? What do you say? How many reductions will be performed? So these type of questions can be framed in the, in like MCQ also, even like numerical answer type also. So you can consider these two questions as numerical answer type. You just have to find the answer and input the values. Clear? So carefully solve the question. Now if we talk about the total number of reductions, so let's do that. To find out the total number of reductions, the non-leaves you have, or you can say the internal nodes you have in the parse tree, that will be your total number of reductions you are going to perform. Remember this point, also write in your notes. Total number of reductions will be the internal nodes in the parse tree, right? Or you can say the non-leaf nodes, both are same thing, right? So let's solve this one. According to this given expression, how we can construct the parse tree here. Let's see this. First of all, we can have this E here, and then this star here, then this T here, correct? Now from E, here I can construct, from E I can get T, and from T I can get F. Now here it is minus and here it is T. Clear? Then again from T I can get F, and here it is minus and here it is T. Clear? Now from F we can directly get the value here. So we need the value which is 4 here, because this is the expression given to us. So 4 will be here, then this 2 will be here, correct? Then from T we can get F, and then from F we can get 4 again, and then from this T we can get F, from F I can get 2 again. So how many, now you tell me, how many reductions will be there? How many internal nodes are there present in this parse tree? Let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 reductions will be there. The answer is 10 for total number of reductions. Is it clear to all of you? I hope it is clear. If you have any doubt, please ask, guys. These are very important questions and you can definitely expect these kind of questions again in the GATE exam. Total number of reductions and the expression evaluation. Okay, I hope it is clear. 10 will be the answer for part B. Let's proceed to the next question now. Question number 2. Yes, guys, quickly answer this question. I hope all of you will be able to answer this question. This is really simple question. What kind of derivation we use in top-down parsers? Yes, guys. What kind of derivation we use? Leaf nodes are not considered in case of reductions. We always consider reductions means we are going to reduce it to the parent, right? So reductions will be the number of internal nodes we have in the parse tree or the number of non-leaf nodes. Is it clear? Yes. Tell me the answer for question number 2 here. Okay, most of the students are saying option A should be the correct answer. So let's do it. Which of the following derivations does a top-down parser uses while parsing an input string? The input is scanned from left to right. So we know in case of top-down parsers, we use LMD, that is leftmost derivation. And in case of bottom-up parsers, what we use? We use reverse of RMD, right? Reverse of RMD. Remember these two. Very important questions. They can ask in 1 mark. Okay. So option A is the correct answer here. LMD we use for top-down parser. That means leftmost derivation. Let's proceed to the next question, guys. Question number 3. If you are going to solve all these questions now, this is going to really help you in your preparation. I'm telling you that. Okay. Yes, that is correct. LMD in top-down and reverse of RMD in bottom-up. Yes, guys. Quickly answer this question number 3, and guys, do share with your friends so that we can reach out to maximum students and they can get the benefit of this class. Because in this session you will get an idea how to solve a previous year question, what is the correct approach, how to approach a previous year question or a GATE question, you can say. In the same way you can do it in the GATE exam also. Okay, let's do it. The number of tokens in the following C statement is, so let's identify the tokens here. This is 1, that is a keyword, printf is a keyword 1. Then you have this, right, open parenthesis, then you have this literal, you are going to consider this as 1 token, then this one, all these are tokens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tokens are there. You can count it. 10 tokens are there. Clear? And if we talk about the types of tokens we have, how many types of tokens we have? Everyone? Yes, guys. How many types of tokens? 5 types of tokens we have. What are those? In short, you can write like this. These are the types of tokens. K stands for keyword. I stands for identifier. S stands for special symbols. C stands for constants or literals. O stands for operators. These are the 5 types of tokens you have. Okay. Is it clear, everyone? I hope all of you know this. If you don't know, then now this is really important. You can note it down in your notes. So let's proceed to the next question now. Question number 4. Yes. Now this is a really important question because now the IITs, they are more focusing on code optimization part. So yes, and you have to prepare this part really well because any type of questions can be framed on this code optimization part. And this is the best question, you can say, one of the best question that can be asked from the code optimization, because multiple techniques of code optimization are applied here in this question. Yes, guys, tell me, what should be the answer here? That is from GATE CSE 2006. If you can answer this question, that means your concepts are quite clear about code optimization, because this is very important question. Multiple techniques can be applied here. Okay, Anshika is saying option B should be the correct answer. Raja is saying option B. Okay, you have to tell which one of the following is false here. Yes, anyone else getting the answer? Kiran is saying option D should be the correct answer. Okay. Yes, guys. Do respond, guys, quickly, because now we are going to solve this question. Okay, let's see this question now. Consider the following C code segment. Now this is the code segment given to you. Which one of the following is false? Teresa is saying option B should be the answer. Okay, let's see option by option. Option by option. The code contains loop invariant computation. Now this is the first term, loop invariant. What is the meaning of loop invariant? First we should understand this. What is the meaning of loop invariant here? So we can say any code is going to be your loop invariant code, which is not going to change even for once, which is not going to change even for once in the loop. Are you getting this point? Loop invariant code means the code which is not going to change even once in the loop. That is your loop invariant code. Now tell me, is there any loop invariant code present here? Is there any loop invariant code present here? Yes it is. Yes it is. Which one? Now if you see this inner loop I modulus 2, this is going to be your loop invariant code for the inner loop. Yes or no? I modulus 2 is going to be your loop invariant code for the inner loop. Clear? What else? 5 into I. 5 into I is also going to be your loop invariant code for the inner loop. Are you getting this, everyone? This is also the loop invariant code for the inner loop. So what you can do is you can place it outside the inner loop. Then also you can use the value. Are you getting this value? Are you getting this concept right, everyone? So that means this code contains loop invariant computation. Yes, it is true. Yes, it is true. Let's move to the next option. There is a scope of common sub-expression elimination in this code. Now what is common sub-expression? When you have the same sub-expression or when you have the same expression and you are using it again in the same way. Like you can see here, 4 into j and 4 into j you are using 2 times. What you can do is you can just evaluate 4 into j once and then you can use it directly. Why to evaluate again and again? Common sub-expression. Common sub-expression we can eliminate here, 4 into j. Is it clear, everyone? So that is why there is a scope of common sub-expression elimination. Instead of writing 4 into j again, we can use its value directly. Yes or no? So that means this is also true. This is also true. What about option C here? What about option C here? There is scope of strength reduction in this code. Tell me, can you perform strength reduction here? Can you perform strength reduction here? If I'm writing 4 into j or if I'm writing j into 4, this is a costlier expression. This is a costlier expression. Instead of that, what I can do? Instead of that, I can write this also. 2 times left shift operation is going to perform the same thing. Yes or no? So that means strength reduction can be performed on this given code. Clear? So this, yes, there is a scope. This is also true. What about option D? What about option D? There is scope of dead code elimination in this code. Now what is dead code? First we need to understand what is dead code. Now dead code is going to be of 2 types. One is your useless, one is your unreachable. Now you tell me, all of you, do you have any code here which is unreachable or useless? Which is unreachable or useless? Do you have any code here? I cannot see. Can you see that? Please tell me. If you can see that, please tell me. Do you have any code which is unreachable or useless here? No, not at all. That means there is no scope of dead code elimination in this code. This is false here. This is false here. Option D is the correct answer for this question. Is it clear to all of you? If yes, then please let me know. Please let me know, guys, and do share it as much as we can, because we are going to solve the quality questions of IIT Kharagpur. So far they have asked in GATE. So that is why we are going to perform, right? That is why we are going to perform loop invariant. See, we talk about unreachable or useless in terms of the complete code segment, not just one part of the code. Is it clear, Raja? We are going to talk about unreachable or useless code in the complete code segment given to you, not just the inner loop or outer loop. Whatever complete code segment, then decide whether it is reachable, whether it is useless, or whether it is unreachable. Is it clear to all of you? Let's proceed to the next question now. Question number 5. Yes, guys. Yes, guys, quickly solve this. Question number 5, again from GATE CSE 2006. Quality questions are there, all of them. You can only combine two loops if they are going to perform the same operation, right? Otherwise no. And as they are nested loops, so you cannot merge them. You cannot merge them. Clear? Loop jamming can be performed when both loops are performing the same kind of operation from same, the initialization is same and the conditions are also same. Then only you can perform loop jamming, loop combining, or loop merging. Otherwise no. Otherwise no. Yes, guys, answer this question now. Question number 5. Yes, tell me the answer. Question number 5. What should be the answer for this question? Very simple question, but very important question, guys. Input is given to you, SDT is given to you. You have to just evaluate. You have to evaluate the output, what this translation scheme is going to print. Yes, guys, tell me what should be the answer here. I'm going to tell you very simple way how you can solve this question, but first you answer this. What should be the answer? Utkarsh is saying D is the correct answer. Okay, Raja is also saying D is the correct answer. Yes, anyone else? Kiran is also saying D is the correct answer. So let's solve it now. Consider the following translation scheme. This is the SDT given to you. Here ID is a token that represents an integer. ID.value represents the corresponding integer value. For an input, this translation scheme prints what? Right? So 2 into 3 plus 4. This is given to you, guys. 2 into 3 plus 4. This is the input given to you, right? Now, what to do? First, you have to identify whether it is L attributed or S attributed. Whether it is L attributed or S attributed. Now, if you carefully observe this SDT, you will find it out that this is your L attributed definition. L attributed grammar, right? How you can say so? Because in case of L attributed, your translations can be present anywhere on the RHS. But if you talk about S attributed, the translations will be present only at the end of the RHS. So that means this is your L attributed. If it is L attributed, definitely you can perform L attributed evaluation only, right? And with that you can find out the answer quickly. So let's do it, guys. Let's make the tree here and find out the answer. So here from S I can get what? E and this R. Clear? Then from this E, what do I get? I will be getting this. I can write F here. Clear? I can write F here. Now from R I can get this star, and here I can get this E. Clear? And here I can write this R also. Clear so far? Now what do I need? I need plus also, and from E I can get plus. So here I need plus, so I can write plus here, F plus E. I'm going to use this production. Later on I will be adding the translations, not now. Later on I will be adding the translations. Okay, yes. Now from F, what do I get? Directly I can write the ID, this one, and we are going to print it. That is the translation, but later on. And here it is your ID. Now from E I can get F, and then from F I can get ID again, and from R I can generate epsilon. So this is going to be your parse tree. This is going to be your parse tree. Now how to solve this question? Very simple. Just find the translation order. Just find the translation order. Now you can see, if you start from the left hand side, if you scan from the left hand side, you will see this reduction is going to have one translation. That means print ID value. So what you can do is you can just directly write here this arrow, just take it downwards, take it downwards. Then what else? Do you have any translation here? No, I don't have any translation for this one, correct? No translation. What else? Again, this is going to have the translation. So just make the downward arrow here. Very simple. You don't have to scan the whole tree. Just on the basis of this, you can write the translations here. What else? You have the translation now. After E, F plus E, then print plus. That means one translation will be there. Just write below. Just write below. What else? Then you have, after star E, you have, in between you have print star also. That means here I'm going to have one translation. Here I'm going to have one translation. This is the final translation. Now just scan from the left to right. What it is going to print? That is going to print the value here, which is ID. That means 2 here. This is 2, right? So 2 is going to print. Here 3 is going to print. This one will print 4. What about this one? F plus E. This is print plus. So print plus here. And then the last one will print star. So this is going to print star. 2, 3, 4 plus star. That is going to be the answer. The output is going to be 2, 3, 4 plus star. What is this? What is this? This is nothing but the post-fixed evaluation. It is converting into post-fix. It is converting into post-fix. Yes or no? Everyone? Yes or no? Yes. So that is going to be the answer. That means option D is the correct answer for this question. Option D is the correct answer for this question. It is converting into post-fix expression. Yes guys, next question on your screen. Question number 6. Be quick. And guys, do share this session with all your friends, those who are preparing for GATE exams, so that they can get the maximum benefit of this class. Okay? Yes, tell me. एक एक क्वेश्चंस को बहुत अच्छे से सॉल्व करेंगे and will make it so easy for you, so that if you can understand each and everything, you will be performing well. If any question like this will be asked on these concepts, you will be able to do well definitely. I can tell you that. All the questions we are going to perform in the best way possible. Yes guys. Tell me, what should be the answer for this question number 6? That is again from GATE CSE 2006. And I can tell you that the way I'm going to solve these questions for you, you will never get any kind of, the technique we are going to solve this question. The approach, this approach you will never get anywhere. I can tell you that for these PYQs. Yes guys, what should be the answer? Raja is saying option A, Kiran is saying option A, Anshika option A, Sashikala option A, Ankur option A. Very good, all of you, very good. That is the correct answer here. Let's see this. Consider the following grammar. This is the grammar given to you. In the predictive parser table, M of the grammar, the entries, these are the entries we are talking about respectively are. Very easy question, very easy question. It's not a difficult question. It is based on LL1. It is based on LL1 top-down parsers. Just make the table. To get more clarity, make the table and then find out the answer. Here in the rows, what to write? The non-terminals, S, F, R. These are the non-terminals you have. What about the terminals? You have star. What else? You have ID. What else? You have dollar. Dollar is a special symbol that indicates end of the string, end of the input. But we are going to write it here. So this is your LL1 table. Yes. Now S comma ID, S comma ID, S comma ID. How to get? Find the first of S. What is first of S? First of S is first of F. What is first of F? That is ID only. That is ID only. That means in the ID column, you are going to write this production S derives FR. Is it clear to all of you? Yes. What else? We need to find R comma dollar. That means rth row and dollar column. How to get that? As we can see, this R is deriving this epsilon. So you have to find the follow of R. You have to find the follow of R. In case of LL1, whenever the left hand side is going to derive directly the epsilon, find the follow of left hand side. What is follow of R here? Follow of R. Follow of R is follow of S only. Follow of S is dollar only. Follow of S is dollar only. Is it clear to all of you? So now that means in the dollar column, in the row R, I can write directly R derives epsilon. These are the entries we are going to get in the respective fields. Option A is the correct answer. Is it clear, everyone? If you have any doubt, please ask. Yes, guys. All clear so far? Option A is the correct answer. Let's proceed to the next question now. Question number 7. And guys, do solve this. Yes, yes, very good, all of you. All of you are solving this question correctly. Yes, guys, quickly solve this question number 7. That is again from GATE CSE 2006. After attending this session, I can guarantee that you are going to learn something new from this session. That is for sure. That is for sure. Even if you have covered all the concepts, still you are going to learn something new from this session. You may learn some concept, you may learn some approach to solve the question. Definitely you will be learning something new. Yes, guys. Kiran, option D. Tahir, option D. Ankur, option D. Very good, all of you. Let's solve this question now. Consider the following grammar. This grammar is given to you. Consider the following LR0 items corresponding to the grammar above. So these are the items given to you. Now what it does say, given the items above, which two of them will appear in the same set in the canonical set of items for the grammar. So that is going to appear in the same set. Now here, if you carefully observe these three items, you will identify that if we are going to have a shift, on this terminal star, then only we are going to have this production, right? And if you are going to have a go to move on this F, so you are going to have this F dot plus E. Can you have these two in the same set? Not possible. Can you have these two in the same set? Not possible at all. What about the next one? If you have shift on plus, then only you are going to get this F plus dot E, right? Because you are going to shift on this terminal plus. That means there is no chance that you can get all these in the one set. That is not possible in this case. Not possible in this case. D, none of the above is the correct answer. You cannot get any of them, any of the item in single set. No, that is not possible. D is the correct answer for this question. Let's proceed, guys, to the next question. Question number 8 now. GATE CSE 2014 set 1 question. Yes, guys. Quickly solve this and let me know what should be the answer for this question number 8. Yes, Anshika, that is correct. All are present in the different canonical set. Yes, guys, quickly solve this question. Question number 8. Now this question requires just the common sense. This question requires just the common sense to solve this question. If you have the common sense, if you have the presence of mind, you can easily answer this question. Otherwise, you need to work on your presence of mind. I would say that. Yes, guys, what should be the answer? Raja is saying option D. Tahir is saying option D. Kiran option B. Utkarsh option D. Ankur option D. Anshika option D. Let's see this now. Let's solve this question now, all of you. A canonical set of items is given below. On input symbol, the set has. Now first observe, do you have this symbol? Do you have this symbol here in this grammar? Not at all. That means there is no chance. There is no chance of SR or RR conflict. No chance at all. Clear? So neither it is a shift reduce nor it is a reduce conflict, because the symbol it is talking about, that is not present in the grammar. What if I say on this input symbol? Now you tell me what kind of conflict will be there. Yes, all of you. What kind of conflict will be there if I'm talking about this input symbol? If this canonical set of items is given to you. Yes, guys. What should be the answer in that case if this is the input symbol given to you? Yes, yes. Yes, Raja, it is possible that they have committed the silly mistake, or maybe they were just checking your presence of mind, right? The aspirants that were going to. Yes, tell me. Now, if you are going to have this input symbol, definitely you are going to have what? SR conflict. SR conflict will be present if this is the input symbol given to you. Just see this, consider this as one state. Reduce item, shift on this. Clear? So SR conflict is present in this case. SR conflict is present, Anshika and Raja, if this is the input symbol. But here it is talking about this one, so neither a shift reduce nor a reduce conflict. D is the correct answer for this question. Clear? Let's proceed to the next question. Very important question again. GATE CSE 2014 set 1. Yes, guys. Yes, Kiran, in that case, there is no conflict. Okay. If whatever is given, according to that, there is no conflict. Yes, guys. Very important question again on code optimization. Guys, prepare code optimization thoroughly because this is going to be really important. Now you can expect in every year you can expect the questions from this. And as you know, in from GATE 2021 onwards, they have increased the weightage of the compiler design also. Now they are asking the questions up to 7 to 8 marks. If you talk about the weightage of CD, that is 7 to 8 marks. You cannot neglect this subject at all. Raja, again check that. SR conflict will be there if you are using this symbol. Okay. If you are going to shift, if you are going to make a shift on that symbol, then SR conflict will be there. Now tell me about this one. What should be the answer here? Which one of the following is false here? Yes, guys. Raja is saying option C. Ankur option D. Sashikala option B. Utkarsh option C. Okay, Kanchan option A. So that means we are getting all the options from your side, right? Now let's see which one is correct. Which one of the following is false? Option A. A basic block is a sequence of instructions where control enters the sequence at the beginning and exists at the end. Now just add few more things here without any jump or halt. This is the definition of basic block. If you have a basic block here, suppose A is equal to B plus C, D is equal to E plus A, something like that. If I'm calling this as basic block, that means the execution will start from here without any jump or halt. You are going to execute all the statements sequentially and then you are going to exit. This is your basic block. If you are going to have any jump here or any halt here, that is not your basic block. So this is the correct answer. Is it clear to all of you? Is it clear? So this is true here. This is basic block. What about option B? Available expression analysis can be used for common sub-expression elimination. What about this? Is it true or false? This is also true. Why is it so? Because in case of available expression analysis, you just check whether the expression is already available in the code or not. If it is already available and if you get that expression again, then you are going to eliminate it. Clear? So that is also one kind of analysis that is there for common sub-expression elimination. We can use it. So this is also true. What about option B? Live variable analysis can be used for dead code elimination. This is also true. Live variable analysis. Why we do that? We do that because we can identify the dead code elimination. We can identify dead code and then we can eliminate. So it can be used for that purpose as well. What about option D? X is equal to 4 into 5 implies X is equal to 20 is an example of common sub-expression elimination. Is it true? No, it is not. It is false. Why is it false? Because this is an example of constant folding. Not common sub-expression elimination. Is it clear? So basically we are folding the constants and we are making it X is equal to 20. So this is constant folding. This is not example of common sub-expression elimination. Algebraic simplification is different. Algebraic simplification, you can have something like this: a plus 0. This is your algebraic simplification. If you are having something like this, b plus, suppose we are writing something like this, b plus 1 or something like this, so we can eliminate it. Okay, I mean we can do this algebraic simplification if it is required, if we know the value of b already. Clear? So this is your algebraic simplification. Or we are writing b star 1, b multiply by 1. So there is no need to write 1 here, because we know b multiply 1 will be b only. So these are the examples of algebraic simplification. This is your constant folding example. Clear? Is it clear to all of you? Yes, Sashikala kindly explains common sub-expression elimination. If you have the same kind of expression here, suppose if I am writing a is equal to j multiply by 4, and later in the code, suppose I am writing again b is equal to j multiply by 4 plus c, for example. Now why to write j multiply by 4 again and again? If we are going to just use it again, we can use a instead of that, a plus c. So this is your what? Common sub-expression elimination. Is it clear? Is it clear to all of you? Okay. So this is constant folding in case of option D. That's why it is false. Let's proceed to the next question now. Question number 10. Yes, guys, quickly solve it. Numerical answer type question. GATE CSE 2014 set 2. NAT question. Very, very important question. And simple also, right? I would say this kind of questions you can also expect in the aptitude part, right? Because there is nothing like you need any concept here, right? Obviously parse tree is there, but still I would consider that as your aptitude part. In the aptitude part. Yes, guys. What should be the answer here? Shashikala is saying 6. Kanchan is saying 6 should be the answer for this question. Ansika is also saying 6. Utkarsh 6. Let's solve this question now. Consider the expression tree shown below. Each leaf represents a numerical value which can either be 0 or 1. Overall, all possible choices of the values at the leaves, the maximum possible value of the expression represented by the tree. That means the value which will be evaluated at the root node, you have to find out that. Now here, if you carefully observe, either you can take 0 or you can take 1. Here it is plus. So what I can do is, I can take 1 here, I can take 1 here, I will be getting 2 here. 1 plus 1 is 2, right? But now if you see, there is minus and again there is minus. So if you have something like this, so it's better to get the smallest value possible here so that we can make it positive. So to get the smallest value possible, how is it possible? If I take suppose 0 here and 1 here, that is the smallest value possible, I will be getting minus 1 here. Yes or no? I will be getting minus 1 here. Now 2 of minus 1, it will become what? It will become 3 only. So here I am getting 3. What about this one? What about this one? Here we are going to have plus later on. So what we can do is, we can have the maximum value possible, because later on we are going to add that value. What will be the maximum value possible here if there is a subtraction? So if I am going to have 1 here and 0 here, this is going to be the maximum value. So 1 here and here, this is plus. So let's take 1 and 1. 1 plus 1 will be 2. 1 plus 2, it is 3. And finally I am performing this addition operation. So 3 plus 3 will give me 6 as the answer. 6 is the correct answer for this question. Very good, all of you, those who have answered it correctly. But the important point is, you should know how to solve it. Yes. Let's proceed to the next question now. Question number 11. Yes, guys, from GATE CSE 2014. Yes, guys, quickly solve it and let me know what should be the answer here. Which one of the following is not performed during compilation? Very simple question, very easy question, direct question, 1 mark question, just answer it. Yes, guys, which one of the following is not performed during compilation? What should be the answer here? Kanchan is saying option A should be the correct one. Tahir is saying option A. Okay. Yes, guys, come on, quickly. Utkarsh is saying option A. Okay, everyone is saying option A now. Yes. Let's see this question now. So here, which one of the following is not performed during compilation? Dynamic memory allocation. Can you perform it during compilation? No. Runtime. At runtime only you can do it. At runtime only you can do it. So this is not performed during compilation. Type checking. Yes. Semantic, SDT, semantic analysis phase. In semantic analysis phase, we do type checking, and that is part of compiler. That is part of compilation process. Correct? So this is performed during compilation. Symbol table management. All the phases of the compiler is going to use symbol table for storing the information and for retrieving the information back. Right? So that also comes under compilation. Inline expansion. Yes, it is also part of compiler optimization when you are going to replace the function call with the function body. So that is inline expansion. You have two types of expansion. One is macro expansion. Another one is inline expansion. What is macro expansion? If they ask you here macro expansion in place of inline expansion, then that is also going to be correct. Why is it so? Because that is outside the compilation process. Macro expansion will be done by your preprocessor. All the statements hash defined, all hash defined statements, that is going to be replaced by the preprocessor. That is, suppose if you have x and 10 here, wherever you have x in the program, that will be replaced by 10, and that is being done by preprocessor. That is before the compiler. That is part of optimization, you can say. Inline expansion, that is part of compiler optimization only. Clear? So that is there in the compilation process only. So A is the correct answer for this question, because dynamic memory allocation, you cannot do it at compile time. Only at runtime it is possible. Yes, guys. Question number 12. Question number 12. Yes, quickly. Very simple question, direct question. And you can easily answer this question within 30 seconds. I can tell you that within 30 seconds. Yes, guys, quickly. Just 3 to 4 more questions are left. Total 16 questions we have. Now we are at question number 12. So yes, do it quickly, all of you. Tell me what should be the answer here. Okay, Anshika is saying option A should be the correct answer. We'll see. Yes, guys, quickly. All of you. Tahir is saying option B. Okay, Raja is saying option B. Yes, guys, quickly say this. Consider the grammar defined by the following production rules with two operators, star and plus. We just have to find out their associativity. Why? When we talk about associativity, when we are talking about the same operators. When we talk about precedence, when we talk about the different operators, then only we talk about the precedence. Now here it is asking about the associativity. So that we can identify on the basis of whether there is a left recursion or right recursion. Now here if you see star is present here, you can see there is left recursion. So if you have left recursion, you can say star is your left associative. Star is left associative here. What about plus? You can see right recursion is present. So as right recursion is present, you can say plus is having right associativity. So according to this, option B is the correct answer for this question. Very good, all of you, those who have answered it, and those who haven't answered this question correctly, I hope you got the concept right. Option B is the correct answer here. Let's proceed to the next question. Very frequently asked question. Now this is based on DAG. DAG is very important topic in this code optimization and this ICG. So basically in ICG we have this, one of the representation of ICG is DAG. We have syntax tree also, correct? We have 3 address code also, and we have other also, like SSA is also there, single static assignment. Yes, only answer one time right. Don't answer one question multiple times. Okay. Yes, guys, quickly solve this. Very important question. Minimum number of nodes and edges you have to find out in the DAG representation, and this is again from GATE CSC 2014 set 3. Yes, guys, quickly solve this. Very important question. Now in this question you will learn one more thing here, okay? Those who don't know how to solve this question, yes guys, quickly solve this, then I'm going to solve this question for you. Tell me what should be the answer here. Ankur is saying option A should be the correct answer, okay? Yes guys, quickly, be quick. Raja is saying option B should be the answer. Let's see how many of you will answer this question correctly. Yes guys, do it. Sashikala is saying option B should be the correct answer here. Guys, keep this in mind whenever we talk about this, whenever this 3 address code is given to you and you have to write the DAG, so always find out the what? Find out the expression. On the basis of expression, it will be easy for you to make the DAG. Okay? Yes guys, what should be the answer here? Convert this 3 address code, this given 3 address code into expression. Yes, Raja is saying B hi hoga. So let's solve it now guys. Consider the basic block given below. The minimum number of nodes and edges present in the DAG representation of the above basic block respectively are. Now always see what we are calculating in the end. We are calculating A. So A is equal to E plus B. There is dependency. There is dependency on E. So can I write like this? So here I'm going to solve this. So can I write A is equal to, instead of E, I can write D minus B plus B. Yes or no? Yes, we have to simplify. We have to simplify. Even after ICG phase, like after ICG phase, you perform code optimization, right? So this is part of code optimization. We can do this. Even in ICG phase also, we can do this type of simplification. Cancel out. Cancellation law will be applied. A is equal to D, you are getting so far. What else? Again dependency we had, D is equal to B plus C. So can I write A is equal to B plus C here? Yes or no? Can I write like this? A is equal to B plus C here. Now again dependency is there on C. So in place of C, I can write A plus D. I can write A plus D. Yes, I can do. Now again dependency on A. So A is equal to B plus C. It should be B plus, instead of A, in place of A, I will be substituting B plus C, right? And rest is as it is. I can even write it as 2B plus C plus D, or just keep it as it is. Then also you will be getting the answer. Now see here, I'm making the DAG for it. So here it is plus, here it is B. There will be 2 edges like this because we are performing B plus B plus. Then I'm going to perform C plus C, then I'm going to perform plus D. So this is the DAG here. This is the DAG for this given basic block or for this given 3 address codes. Clear? Is it clear? How many nodes and edges? How many nodes and edges? Count all the nodes here. 1, 2, 3, 4, 5, 6. 6 nodes are there. What about the edges? What about the edges? 1, 2, 3, 4, 5, 6. 6 edges are there. 6 and 6 is the correct answer for this question. Is it clear? 8 and 10 you will get, but that is not the, you can say, optimized one. That is not the optimized one. 6 and 6 is going to be the correct representation, and the optimized one if we are representing this given basic block through DAG. Is it clear, everyone? If you have any doubt, please ask. And let's proceed to the third last question of this session. Question number 14, again from GATE CST 2014, set 3 questions. Yes guys, be quick. Yes guys, do it quickly. Tell me the answer. You should not take more than 1 minute for this question. Even you can answer within 30 seconds, but I would suggest you to give at least 1 minute to these type of questions so that you don't commit any kind of silly mistake even in the GATE exam. So read all the statements carefully and then only mark your answer. Give 1 minute to it and let me know. What should be the answer for this question number 14? Yes, even if they don't mention, Raja, about simplification, you have to get the optimized one only. Even if they don't mention, always go for the optimized code. Clear? Yes, Tahir is saying D should be the correct answer for this question number 14. Anyone else getting the answer? Okay, someone anonymous is saying option C should be the answer. Let's see here. Let's see here. Which of the following statements are correct? Statement 1. Static allocation of all data areas by a compiler makes it impossible to implement recursion. That is true. Why? Because in case of static allocation, only once. Whatever function you have, suppose you have function f, the activation record for this function will be created at the compile time only. Are you getting this? But if you are having some recursive call, in that case, in case of static allocation, you cannot implement recursion. Clear? So because you have to make the activation records again and again depending upon the recursion. Clear? So this is correct. This is true because it makes impossible to implement recursion. Second statement, automatic garbage collection is essential to implement recursion. What do you say? Is this necessary? Is this essential? No, it is not. No, it is not. C language, C++, they don't implement automatic garbage collection. Still we can use recursion, right? We can implement recursion. That is possible. Only Java language we have that uses automatic garbage collection, right? So that is not essential, not related to this implementation of recursion. Dynamic allocation of activation records is essential to implement recursion. Definitely yes, right? You have to create the activation record dynamically when you call the function, when you call the procedures. So yes, it is true. Yes, it is true. Automatic garbage collection means you are freeing the memory, and that is done by one daemon thread. Like if you have studied Java, so there we have this. No, this is not important from exam point of view. So Java uses that daemon thread that is going to collect the garbage. That means the memory which you are not using but you occupied before some time, that is going to free. That is going to free. Clear? That is the feature of automatic garbage collection. Now come to this last statement. Both heap and stack are essential to implement recursion. Is it so? One of them will suffice. One of them will suffice here. Yes, that is correct, Raja. Yes, Shirisha. Free we used in case of this C programming, right? Now, both heap and stack, both are necessary, or either one of them will suffice. If you have heap, then also you can implement recursion. If you have stack, then also you can implement recursion. Clear? We have to do it. We have to do it, right? It does not happen automatically. We have to use free function to free all the dynamically allocated memory. Yes or no, everyone? As Shirisha said also. Yes, so only one of them will suffice. Only one of them will suffice. That means this is also false. This is also false. Clear? 1 and 3 is the true statements here. Option D is the correct answer. I hope it is clear to all of you. If you have any doubt, please ask. Let's proceed to the next question now. Question number 15. Very simple question. You can expect this in 1 mark, this type of question. Yes, guys. Quickly, tell me the answer. Yes, yes. Quickly answer this question. Question number 15. You can implement. If you have heap, then also you can implement recursion. If you have only stack, then also you can implement recursion. Okay. Yes, yes, Tahir, that is correct. Yes, guys, tell me the answer. Risha is saying option C. Nishu is saying option C here. Let's see this now. One of the purposes of using intermediate code in compiler is to increase the chances of reusing the machine independent code optimizer in the other compilers. That means to enhance the portability of the compiler. Yes or no? That is the one of the purpose of intermediate code phase in the compiler. Yes or no? Option C is the correct answer here. Option C is the correct answer here. Clear? Let's solve this last question now. Question number 16. Yes, guys. Last question of today's class. again from GATE CSE 2015 set 3. Very good question. Yes, what is your doubt, Tahir? Please ask in the chat box. Quickly solve this question. Last question, everyone. Yes. The minimum number of arithmetic operations required to evaluate this given polynomial using only one temporary variable. Yes, tell me. What should be the answer here? Yeah, that is true. That is true. In case of stack, as you as you finish the execution of that given function, activation record will be deleted. That is there. Yes, that is correct. But that is not automatic garbage collection. That is not automatic garbage collection. Okay. Is it clear? Yes, guys, quickly solve this question number 16. But when we allocate the memory like malloc, we use calloc, right? To allocate the memory dynamically in heap section. For that purpose, you need some function. In case of C programming, we use free function. Okay. Ankur is saying 7 should be the answer for this question. Yes, guys. So let's solve this question now. The minimum number of arithmetic operations required to evaluate the polynomial this. So this is the polynomial given to you, x raised to the power 5 4x cube plus 6x plus 5, right? So what we can do is, if I take common x, what do I get? X raised to the power 4 plus 4x square plus 6 plus 5, correct? Now here I will tell you, those who are not getting how to solve this question, just see this one. Here, if I again take x common, what do I get? X cube plus 4x, right? And here it is plus 6, here it is plus 5. Then if I take again x common, what do I get? X square plus 4 plus 6, right? And here it is plus 5. Clear? And if I take again x common, so why we are doing this? So that we can use just one temporary variable to perform each and every operation. You will see that. I will explain you. Just wait. And here I can write just x and then this plus 4, right? Then this plus 6 and then this plus 5. Is it clear, everyone, so far? Now I can store this x into, or you can consider this x as one temporary variable. Let's consider that x. Then we can perform x into x, and then you can store again in x. Then you can perform plus 4, then into x, then into x, then plus 6, right? So in one temporary variable, we are going to store the result as soon as we are performing the operations. Clear? So only one temporary variable we need. But how many arithmetic operations we are performing? So you can see 1, 2, 3, 4. 4 multiplications we are performing. 4 multiplications we are performing here. And how many additions? 1, 2 and 3. 3 additions we are performing. So how many arithmetic operations in total? 7 arithmetic operations we have to perform to evaluate this polynomial using only one temporary variable. Is it clear? Is it clear, everyone? 7 is the correct answer for this question, because you can use just one temporary variable and you can store the result into that. Clear? Is it clear to all of you? Yes, that is the answer. I hope, guys, you enjoyed this session. I hope you have learned something new from this session. I can guarantee that something you have definitely learned from this session, right? Maybe the concepts, maybe the approach to solve the question, right? So that's it, guys, from my side. That's it from my side. And guys, do share this session as much as you can, because in some days again I'm going to take one session like this. I will be taking one session on operating system, and I will be covering all the IIT KGP questions from year 2000, from year 2006, from year 2014. All these 3 years we are going to solve OS questions. So wait for it. And you can also join my Telegram group if you want to get the PDF of this class. I will be posting the PDF in the Telegram group. Also, I will be posting the notifications. So the link is cs_by_Anshul_sir, or you can even message me on my Telegram. I'm giving you my number, all of you. So this is my number. You can even message me on Telegram. I will add you to that particular group. Okay, is it fine? Yes. Thank you all of you for joining this class. Good night, take care, and bye bye. Thank you all. Yes, Raja, very soon I will be starting the app classes also. Yes guys, take care, good night, and bye bye. Thank you all.